Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain the coordination compound. The topic is double salt. How it is related with coordination compound. What is the relation between double salt and coordination compound? In part 1 and part 2 I have explained what is in coordination compound and what are the Werner's coordination theory. Now here I am going to show you what is the meaning of double salt and what is the meaning of coordination compound. Now here double salt means they are the addition compounds. When you see the formula you feel that it is an addition compound. See example, carnellite. Carnellite means KCl, MgCl2, 6H2O. That means potassium chloride and magnesium chloride with 6 water molecules of crystallization, and these are the addition compound. Now you can see it is mixture of KCl, MgCl2, but it is water of crystallization of 6 molecules of water. Stable in solid state. When you see carnellite, it is a solid one, it is stable, and now breaks into constituent when dissolved in water. Means if you are this carnellite to water, it becomes an aqueous solution. This aqueous solution shows the properties of the constituent. What are the constituent here? K plus Cl minus, Mg plus 2Cl minus. That means when you are water or when you say that is dissolved state, the aqueous solution is prepared, and here it shows the properties of each constituent. So now the aqueous solution of it carnellite shows the properties of K plus Cl minus, Mg plus 2. That means when you do that acid radical analysis and basic radical analysis, it shows the property, it shows the experiment practical test here of potassium and magnesium. Now similarly chloride, that is one type of acid radical. In acid radical also it shows the experiment, observation, inference. It shows the test of chloride. That means when you add silver nitrate and chloride, it gives cloudy white precipitate. Similarly here potassium magnesium test, when you do, it will observe that K plus and Mg plus 2 ions are present. Similarly example, more salt. More salt, one example, let the name actually these are the named according to scientists who discovered it. Now FeSO4. What is FeSO4? Ferrous sulfate, NH4 whole to SO4. That means here this is NH4 whole to SO4 ammonium sulfate having 6 molecules of water. That means you can say that is an addition compound because 2 compounds are there, these are ionic compounds, and with they form with 6 water molecules forming crystallization. And now solution shows the properties of what? Fe plus 2, SO4 minus 2, NH4 plus 1. That means it shows the property, it shows the test of basic radical, that is ferrous. Ferrous means Fe plus 2, ammonium. Ammonium means NH4 plus 1. Similarly, it shows the acid radical test of sulfate SO4 minus 2. When barium chloride solution is added, white precipitate is formed, which indicates that sulfate is present. Potassium, aluminium, sulfate whole 2. See, potassium, aluminium, potassium is plus 1, aluminium is plus 3, and so that is why plus 4, and sulfate is minus 2. So the formula becomes KAlSO4 whole 2, 12H2O. Now the solution shows the property of K plus, Al plus 3, SO4 minus 2. That means it shows the property of potassium, aluminium, sulfate. So what it indicates? The double salt means it an addition compound. It is an addition compound which gives the idea what are the ionic compounds are present with how many water molecules that is crystallized. So it is a crystallization structure, but here you can say KCl MgCl2 6H2 carnallite, it is solid and stable. When you add water, it is not stable, it forms ions. What are the constituent? Ions are present. And now it shows the properties of by acid radical and base radical test. Similarly, more salt and potash alum also they show the property of each constituent when it dissolves in water, when it is an aqueous solution. It shows the property of each constituent. What is double salt? It is clear to you. Double salt is an addition compound where the individual constituent never lose their properties. Now here coordination compound. Coordination compound is also an addition compound but retain identity of their individual properties. That means retain identity in solid and solution state. Again see addition compound, these are also addition compound and retain their identity in solid and solution, in aqueous solution also having same identity. Individual constituent properties are lost. Suppose inside the square bracket if potassium is there, chromium is there and chlorine is there, they lose their properties. They never shows any acid radical test, any base radical test. Example C, K4FeCN whole 6 square in square bracket this one, and this is actually complex anion because having minus charge. And what is the name? Later we will see, and I will explain how the nomenclature is done and how can you name it. Only remember this is K1 plus 1 into 4, this is plus 4. It is plus 4, so to clear the counteract, that is minus 4. And now minus 4 mean here Fe is plus 2 and Cn is minus 6, that is why it is minus 4. Again I will clear when I will go to nomenclature, at that time it is clear. Now only listen, this is minus 4, this is plus 4. Minus 4 and having this complex anion do not dissociate into Fe plus 2 character properties, basic radical, and Cn minus that is acid radical. That means what happened here, inside the square bracket what is there, that is called complex ion, and complex ion are two types, either it is positive or negative. Now in this example it is negative. Now here Fe is plus 2 and how I will clear, and Fe plus 2 and Cn is minus 1. And now here when you add water, this water to it, an aqueous solution will form, never dissociate into Fe plus 2 Cn minus 1. It only gives the character of this act as a 1, that is called here, that means here it will act as 1 within square bracket, complex ion is 1. And before the double salt what happened? Every constituent ion is free in solution stage, and then you can do any base radical or any acid radical test. But here the complex ion is 1 and inside it what basic radical or acid radical present, they never shows their properties. The character, the properties are lost. Similarly, example inside square bracket nickel and NH3 whole 4. That means nickel is there, ammonia is there inside the square bracket, and it is plus 2 charge and minus 2 charge. Chlorine is minus 1, that is why minus 1 into minus 2, so it is plus 2, and nickel is plus 2. Because ammonia, that is a ligand which has neutral molecule which has 0, charge is 0. That means you can see inside the square bracket what is present in solution, and never dissociate to Ni plus, never dissociate to NH3, never shows the character of ammonia. There is no smell of ammonia, there is no taste of nickel plus 2 basic radical. That means here NiNH3 whole 4 square bracket over plus 2 charge that act as one identity. That means here plus 2 charge and having square bracket, that only one complex ion. and never shows what is inside it. Nothing. It shows a new property. It shows a new property, new color. So it is known as complex ion, and form compound is coordination compound. Similarly, copper NH3 whole 4 square bracket over plus 2 SO4 minus 2. See here also chloride ion is outside the square bracket. It is not related to square bracket. See in this example, chloride ion is outside the square bracket. It is not related to that what coordination complex ion. That is why it shows the property of acid radical chloride. When you treat silver nitrate, it gives cloudy white precipitate, 2 molecules, because here 2 moles molecule, 2 moles it gives, because here 2 chlorine, 2 chloride ions are there. So example here also you can see outer side complex ion sulfate ion is there. Inside it CuNH3 whole 4. That means it acts as only one identity, that is complex ion, that is positive, complex cation. Now here what happened? It never gives the property of Cu plus 2, never shows the base radical test of Cu plus 2, never shows the smell of ammonia. That means it gives a new compound, new complex ion which never shows the identity which is inside it. What is the individual constituent inside it, they never shows their properties. That means here never dissociate into Cu plus 2 and NH3. But it shows the property, acid radical property of sulfate. When this one treated with barium chloride solution, it gives white precipitate. That means 1 mole of sulfate ion is present, because 1 mole of barium sulfate is produced. That is why it is only 1 sulfate ion, 1 mole of barium sulfate is produced. Again see what is coordination compound double salt. Double salt means the constant present, that is stable in solid state, but when you add water it becomes aqueous solution. Then here the constants are free, K plus, Cl minus and SO4 minus 2, like this. They are free. They show the test of that means acid radical and basic radicals respectively. But when coordination compound is there, the complex ion is there within square bracket, that behave as one identity, behave as one complex ion, and it shows a different property from their constituent, what is present inside the square bracket, what are present inside the square bracket, and their property, and the complex ion whole, the property total different. That means here inside it what constituents present, they lost their identity, they lost their properties. Here you can say the complex ion is a new one. Complex ions are 2 types, one positive and negative. So inside it what are present, they never shows the properties of each constituent. Properties of each constituent mean here copper ammonia, here nickel ammonia, here ferrous Fe plus 2 Cn minus, they never shows the property of Fe plus 2 and Cn minus. So I hope it is clear. Double salt and coordination compound. Coordination compound totally different from double salt. I hope you will subscribe my channel B.L.DASH, short and sweet in chemistry. And thanks for watching my video. In coming video I will tell some terms. I will explain some terms which are related to coordination compound, because coordination compound is totally different chapter from other inorganic chemistry chapters. That is why I will explain some terms which are related to coordination compounds. Thanks for watching my video again. Thanks to all.